Results and relative motion is our new topic, but please don't forget to subscribe to the channel. Okay, so this one is a very nice topic. It deals with most cases we're going to see vectors as simple as that. So we are going to go through the basics. Then after we are going to go on as we improve until when we finish the whole. Okay, so let's start with the basics. The resultant of given velocities is basically if they give you two vectors or three vectors or four vectors in a vectorial notation, in ij or ijk notations, it means that to get the resultant of any vectors they give you, it is as simple as getting their sum. So, for example, if they give you v1 equal to this and v2 equal to this, and then they want to get the resultant vr, then you sum v1 and v2 as long as they are giving it to you in a vector, in a vectorial notation form. So ai plus bj means that this one is there. You can write them in a column form. So this one is a, b, then this one will be k1, k2. Then you sum them with ease. So when they give you vectors in a vectorial notation, then that is the easiest to get the result. Just sum them. Okay. But if vectors are given in terms of magnitude and their direction as angles, then you can express velocities in vector form and we find the magnitude and direction of the resultant and the two velocities. And for two velocities, we can use parallelogram of forces. Parallelogram of vectors. Like we saw in the forces, the parallelogram of forces, even in the same case, is what we are going to use here. If they give you the direction in terms of the angle and then they give you the magnitude of the vector. As simple as that. So the moment you know the parallelogram of forces, then the parallelogram of vectors is going to be very easy, as we saw. So that's the case. So if they give us the vector and they give us its magnitude and direction, simply we can use the parallelogram of vectors as we are going to see. When that's possible with these simple ones, we are going to come to this. Find the resultant of the velocities, this and this. So now they are in vectorial notation, so meaning our resultant VR is going to be V1 plus V2, which is going to be our V1 is 1, 3, then plus V2, which is negative 4, negative 2. And from there, it's got our resultant vector. Our resultant velocity is going to be this plus this, which is negative 3, 3 plus negative 2, which is a 1. So that is our resultant, which you can empty now. Give us, you can leave it there, or you can come and say 3i, then plus j, or 1j, as simple as that. Okay, of course they are meters per second, meters per second, if these ones were also in meters per second. Okay, they give us that. Then our result is going to be V1, V2 plus V3 because they are in vectorial notation of I, J, K. So RV1, you see I is 1, you see we are missing the J, so J is 0, then negative 2 as our K. Then plus V2, we have negative 1, negative 4, negative 2. Then plus V3, negative 2, negative 1, negative 1. And so to sum, we get this plus this, that is 0, plus negative 2. So that will give us negative 2. 0 plus negative 4 plus negative 1, that will give us negative 5. Negative 2 plus negative 2 plus negative 1, which will give us negative 5. And so that will be our resultant velocity, which you can give as negative 2i minus 5j minus 5k. As simple as that. Really easy. Okay, so let us apply this idea now onto this. The resultant velocity of V1 and V2 is this. Find L2 and V2. Okay, now that our resultant is equal to the sum of these two. Then when we hear resultant, means that it's the sum of given velocities. So our resultant here, and then that's negative 2, 7. Our V1 is 1, 4. then plus our B2, which is A2, B2. So we want us to get A2 and B2. So it's that negative 2 will be equal to 1 plus L2. As simple as that. So from here, you can set negative 2 minus 1 is equal to A2. Therefore, our A2 will be negative 3. And that is that. When I come now to this, my 7 will be equal to 4 plus B2. Then it's that you can do this in one step, but you lose nothing also doing this. So our B2 is going to be a 3, and that will be the answer. With ease, and you're done. Then here, the resultant just on B1, and the B2 is this. Find A1 and B1. So it tells us that our B resultant point is going to be the sum of those two velocities. So this one is negative B1, then this is B, equal to RB1, which is A1, negative 6, then plus RB2, negative 2, A1. The same idea. When you add this plus this, we shall get that. So negative B1 will be equal to A1 plus negative 2. I bring this inside and take this inside. It's that 9A1 plus B1 will be equal to 2. I call this equation 1. I also come to this. So B1 will be equal to negative 6 plus A1. So now I call this equation, just substitute here. I call this equation 2. And I say put 2 in 1. So from here I have now A1 plus now negative 6 plus A1 equal to 2. If I simplify it, that this will give me 2A1 equal to 2. When I take this beside, it will be 8. So my A1 will be 4. If A1 is 4, then B1 is, when I put here a 4, then my B1 is going to be negative 2. With is. So we have handled that. So these are the basics. They are very easy, as we are going to see. This is the topic for you to smile. Okay, wish you well.